Now let us discuss the first step in transforming our application, that of putting a web application front end. The main solution now has two parts: the web application part and a transformation based on what we had in our console application in the MVC project. So the iCustomer view interface is now reduced to its two fundamental members: the set controller member, so that the view can find out which controller is being used, and write customer, which is something that the controller can use to call on the user interface to write out the appropriate customers. The web page itself becomes the view. Here's its implementation of set controller, which basically takes the controller passed in, and write customer, which takes a list of customers and writes it to the appropriate UI widgets. Within the page load method, the controller is created and set to the view. And then the view has the appropriate events which interact with the user interface and rely on the controller to process the input. The controller itself has the appropriate methods to interact with the model based on the input. And of course, it relies on the view to write out the customers. The web.config file has the appropriate settings so that the customer data mapper is used. And the model is exactly the same as it was before. So now we have a web application front end. So we can add a customer, and then we can get all customers. We can get a customer by ID. We can add an order. Now we get the customer by ID, we get the order number and its associated orders. Since the web app interacted with the application through the model, none of the rest of the application had to change when we changed the user interface. Transforming our application to use SQL Server is very easy. Since the customer manager and the repository layer use the iCustomer Data Mapper interface, they do not care about exactly what class is implementing the data store technology. So all we have to do is define an implementation class, in this case SQL Customer Data Mapper, that implements the iCustomer Data Mapper interface, and then associate that in the web.config file to be the one that the dependency injection container uses. It can't get much simpler than that. So we see, for example, that Get Customers opens up a connection, and depending on whether you're asking for all the customers or single customer, it creates the appropriate SQL command associated with the connection, executes it, and then gets the appropriate orders. If you want a particular one, then you get the name and the order for that particular customer. And in any case, you return the collection that was requested. And again, the save does the appropriate things as well. So again, no other part of the application had to change, all because we were using interface-based development. Now let us see what we had to do to provide web service support. We had to make two modifications. First, we'll look at the modifications on the service side to the business logic layer where we expose the web services, and then we'll take a look at the client side where we consumed the web services. We had an interface called iCustomerManager, which we now transformed to be a WCF interface, basically by making each method an operation contract, defining a namespace for the service contract, and then adding the appropriate request and response classes for the arguments passed in. For example, in the request, we have a contract that passes in the name. Similarly, in the response, we have a message contract that has two message bodies, members, one a name and one an ID. And similarly for the other members of the interface. Then we took the Customer Manager class and converted it to a Customer Manager service class by defining a service behavior and then implementing the method appropriately. Because stateless services scale better than stateful services, we instantiate an instance of the Customer Manager inside each method rather than relying on the factory to generate a singleton. And the final thing we had to do is in the web.config, which is now the front end for the service, we had to add the Dependency Injection Manager key to make sure that the SQL Customer Data Mapper is used in the data mapping layer. On the side that consumed the web services, which is the user interface side, it was also relatively straightforward to put in the web service support. We used the regular WCF functionality to generate a Customer Manager service client, which is the proxy for the web service. We then modified the model to use that proxy. And the model, of course, was the place to put it, because in the MVC pattern, the model in the user interface is where the business logic is handled. Hence, to add this support, we did not have to make any changes to the controller or the view. So here, for example, in Add Customer, we create an instance of the proxy, make the call on the proxy to invoke the web service, take the return from the web service, put it in the model customer class, and then return it. So this is exactly the same interface that the view and the controller expect. So again, no changes to any other part of the application had to be made. So you can see from this simple example how easy it was to take a partitioned application that was layered properly to go from a very simple console application that used an in-memory storage facility of sorted lists to a 3-tier application that used a relational database, all because we had the proper partitioning and layering to accomplish this.